Hey everyone, welcome to 6.2 Notes, Exponential Growth and Decay. I'm going to start with some examples up here at the top. These aren't exactly what we're doing today, but I do want you to be able to see where in the world it's coming from. So, let's say you go to the store and you have an item worth $10 and the price is increased by 9%. That's called tax, by the way. And basically, if you wanted to find out how much that would be worth, you would take that $10 and multiply it by 0.09. Now, why am I using 0.09? Because 9% is the same thing as 0.09. In order to get that, you're going to divide by 100. We're going to write that down here too, so I'm not going to write that out right now. So that means that it's adding 90% or 90 cents to your total. So we have to add the total back in. Okay, so basically you're taking the $10 and you are adding 9% of that $10 multiplication. Okay, and you end up getting $10.90. And then here's where this gets a little bit tricky. What if you don't know what it's worth yet? How could you make something, an equation, so that if you didn't know how many times you wanted to increase it, you could have a formula ready to go? So let's say your original price is X instead of 10. Then it would look something like this. But this is just 1x. And if you add those two together, you technically have 1 plus 0.09, 1.09. Let's try that out. If I had just taken 10 times 1.09, I would have gotten it in one step instead of two. So basically, this is the 100% that we started with, and we added 9%, or 109%. Okay? That helps us because if we wanted to increase the price of the item by 9% multiple times, that doesn't just add 90 cents every time, because now the next one we would be taking 90% of this number and adding it. So 90% of $10.90 is different than 9% of $10. I'm sorry, I think I said 90% at one point. Basically, what I'm saying is you would have to do 10 times 1.09 times 1.09, however many times you wanted to do it. But if you don't know how many times yet, I don't know how far to keep going. So instead, what we do is we write what's called an exponent for how many times we want to do this. Okay? And that's kind of what leads us into what we're doing today. Now, I know that example is probably a little bit confusing for some people, and if that's you, don't worry too much about it just yet. Wait until you see the formula. Okay, so there is what's called an exponential growth and decay formula. Just a reminder that in our last lesson, we talked about how it's A is the initial value, B is our multiplier. That's why this has the exponent, is because that's the thing I was multiplying by. So 1.09 would be my multiplier, and 10 would be my y-intercept, or my initial value, because that's how much it started with. Okay? Now, when we talked about that, I had said if you're multiplying by a number bigger than 1, it's going up, growth. If you're multiplying by a number less than 1, it's going down, decay. So what's going to happen is I'm going to have my final amount A. That's my final amount. And then I'm going to keep this little a that I had out here, the same I had, except for I'm going to call that the initial, or how much you're starting with. That's what initial means. And then inside the parentheses, I'm not just going to put B. This is the only part that's going to be different. We have to do 1 plus our rate. So for this one, 1 plus 9%, 109%, that's what went in the parentheses. So there's actually a formula to figure that out. And then I'm just going to leave my exponent as x. Okay, and then I am going to write that x usually ends up being the amount of time in these problems. So that's why I had used a t up here, but I know that we're more used to x, so I'm going to use x as my variable. And then exponential decay, the only difference is, and I'm not going to write what each letter means because I just did that on the other side, is instead of adding a rate, you subtract the rate. Because if it's decaying, that would be like saying you got 9% off of something. So you would get to subtract it from the total instead of adding it to the total. So this is more like interest. This is more like a discount. Okay? When we put this r into the equation, it is in decimal form. That's why I changed the 9% to a decimal. In order to get the decimal form from a percent, you're going to have to divide by 100. So anytime you're not sure what decimal goes with a percentage, divide by 100 and that's all you have to do. Okay, don't get too tripped up by that. That's why I'm reminding you how to do it now. Okay, let's move down to examples 1 and 2. Okay, so write an exponential function using the information. The initial value is 800. I'm going to start with this a equals that I had. And then the initial value goes in front. That's the 800. Just like in 6.1, the initial value goes in front. And then it's increasing. That's growth. So I'm going to use the 1 plus r. And the rate is 6%. 6 divided by 100 is 0.06 to the power of x. And I am going to write one thing, and that is that you could also write this as like that. So 1 plus 0.06. And what you'll notice, if you do this enough times, is when you add 1 to a decimal, it just puts a 1 in front. And that only works if you're adding it. Now let's talk about decay. You're still going to start with the initial value in front, but instead of adding, you have to subtract. 1 minus 4.5%. 4.5 divided by 100 is 0.045. And then I'm going to go ahead and simplify that too. 1 minus 0.045. Since you're subtracting, it works a little bit different. You get 0.955. Here's why that's different. If you start with 100% and you take away 4.5%, 100 minus 4.5% is 95.5% left. That's where that's coming from. So on this one, you put a 1 out front, and this one you think to yourself, if I take away 100%, what's left? And then over here, we're going to do 3 things. State the initial value, the percent rate, and whether or not it's growth or decay. So initial value is the number in front. That's 375 on this first one. And then here we have something less than 1. Whenever this is less than 1, you have 2 options. Number 1, do some mental math. What percent is missing from 100 if we were at 95? 5%. And it's going down because that's less than 1, so that's going to be decay. Whereas this one starts with an initial value of 10,000. And this one has a 1 in front, so the percent's always going to be the part next to it like that, 23%. And that would be growth because the number in parentheses is bigger than 1. Second way of doing that, if you're not sure what it is using mental math, take the number in the parentheses and subtract the 1. So there's this 1 in front of both of them, here and here. So just subtract that 1 back, and you get negative 5%. Okay? And if you multiply by 100, that will give you back your percentage. So you can divide by 100 to get the decimal form, multiply by 100 to get back to the percentage. Okay? You don't need to write that this is negative 5% because you're already writing that it's decaying, and that's what the negative means. So you don't need to write both. And then down here, if I do 1.23 minus 1, it pretty much just takes away the 1. And again, if you're not comfortable with what percentage that is, multiply by 100, and that tells you your percentage. Okay. Now, let's talk about some word problems. Don't get fooled by 2, 3, and 4. They're going to be pretty easy. 5 and 6 are going to be just a little bit more difficult. And as I say that, I'm going to go ahead and say, hey, let's make this a 6 instead of a 5. If you printed your own at home, I fixed that before I sent the PDF to you guys. So, all right, example 3. Your parents invested $1,000 in a savings account when you were born. That's your initial value. So that's going to be the number that goes out front. The account pays 6% interest every year. That means it's going up, so we're going to do 1 plus. 6% is 0.06. I had just done that right up here too. Okay, that's where this had come from. And then it says how much money will be in the account when you turn 18. That's 18 years after you were born to the day, so we're going to put an 18 up there. So initial, and then either do 1 plus the rate if it's going up or 1 minus the rate if it's going down, and the exponent becomes your time. And then as I type this in, I'm going to type it in exactly as it looks. Actually, I'm going to do one thing. I'm going to type it in like that. So I went ahead and added the 1 and the 0.06. Okay. $2,854, and since this is money, we went around to 2 decimal places. The third decimal place tells me what happens. This is a 9, so it's going to round this up to 34 cents instead of 33 cents. Done. Example 4, Mathville had a population of 12,340, so that's their initial, in 1985. I'm going to box that so I remember it, but I don't need to do anything with that just yet. And then in the parentheses, it says that this is decreasing at 2% per year. That means it needs to go down. So 1 minus 0.02. Okay, again, 2% as a decimal. Oops. It's 0.02. And I'm subtracting because it says it's decreasing. And then it wants to know what the population would be this year. Well, this year is 2021. Hopefully you know that. And I'm going to subtract the original year that it started. So it's been 36 years between 1985 and this year, 2021. So when I say this year in a problem, I want you to use 2021. And then I just need to type in 1 minus 0.02. That's 0.98. Okay. And then all I have to do is 12340.98 to the power of 36. So exactly what I just had over here, I'm putting over here. Now, looking back at this problem, this is how many people there are. So I have to round to the nearest whole person, which would be 5,963 people. I'm just going to put peeps. You can't have 0.85 of a person. Now, there are some people who round down because they're like, you've already lost that extra part of a person, so you got to round down instead of up. Since this 0.85 doesn't count as a whole person, it has to go down. That's fine if you want to round it that way. I don't really care. As long as I can see your work, I'm happy. Then example 5 gets into a little bit different area because Penny's account now has this much money after being invested at 4% interest compounded monthly for 6 years. Do me a favor and cross out the fact that it says compounded monthly. Again, if you printed this from the PDF, I fixed it. I just didn't catch this before I printed for everybody. There is something called compound interest. We will do it, just not in this section. So Penny's account has this much money after being invested. We don't know how much it started with. So this number is going to go on the left. We don't know how much it started with here. We do know that it's going up because it's getting interest. So 1 plus 4% as a decimal is 0.04. I don't like you doing that. Okay. And then we know that the time was 6 years. Now, here's the part where this gets a little icky. You are not done. You don't get to just type this in and go. These two things are being multiplied. We just don't always write the multiplication dot because that would get to be a really big pain if we did it every time. And how do you undo a multiplication? You divide. So all we have to do is divide by 1 plus 0.04 to the power of 6. On both sides. And what that does over here is it cancels it out. And over here, I have to actually do 2859.17 divided by, I'm going to make that 1.04 to the power of 6. And there you have it. That's how much money she started with. And then example 6 gets a little funkier. The price of firewood 4 years ago was $140 per cord. Today, a cord of wood costs $182. I'm going to go ahead and say that this is 2021 and this is 2017. So that way we're using real time here. How much will it cost in 2025? Okay, so now we've got all of it in years. We know where it started and where it ended the first time and how many years it took. But what we don't know is the rate. At no point in here does it give you your percent rate. But this is your final amount. This is your initial. Okay, so I'm going to start with 182 equals 140. This price is going up, right? From 140 to 182. So I'm going to go ahead and write 1 plus r instead of 1 minus r. I just don't know what r is yet. But I do know that it's been 4 years. Now, same way I got rid of this up here, I'm going to get rid of this 140. It's being multiplied, so to get rid of the 140, I want to divide by 140. My whole goal right now is to get r all by itself. And let's see what we've got here. 182 divided by 140 is 1.3. Okay, and then this 140 goes away. Now, how do you get rid of a fourth power? Well, how do you get rid of a power of 2? You square root. How do you get rid of power of 3? You cube root. To get rid of power of 4, you fourth root it. And there are two options you can do. One of them is to type the number 4. Actually, I'm just going to go ahead and do this. You can do a fourth root. I'm going to come over here and say that the fourth root is the same thing as the 1/4 power. right? Because it's really hard to type the fourth root in, especially if you're using your phone. So instead, what we're going to do is take each side to the power of 1/4, because these exponents get multiplied, and 4 times 1/4 is 1. So it's always going to be the reciprocal of the power. And then all I have to do is take 1.3 exponent, and if you're doing this in your phone calculator instead of typing 1/4, you can do 1 divided by 4 like this if you're using a graphing calculator. If you're not, type the decimal for 1/4 like this. Otherwise, your phone calculator will do the order of operations in a weird way. Okay, so that we get 1 plus r equals 1.06778. And now, I can now find how much it's going to cost in 2025 because I know what the rate is. So the whole goal here is that you have to find the rate first. Okay, and I don't need to subtract the 1 to figure out what R actually is, but I can tell that it's like about 6.7%. All I do have to do is know that my final amount is 140. Now I know what goes in the parentheses. The power of 2017 to 2025 is 8 years. Once again, this goes in the parentheses, so now I have a complete problem. 2017 is where it started, 2025 is where it's ending. That's 8 years. 140, 1.067789972. I would highly recommend using all the decimal points that you have. Don't round this early in a problem. Don't round until the last part, because otherwise it will give you a different answer. And we've got $236, and this is going to round me up to 60 cents. Okay, we are talking about money again, so you can round to 2 decimal places.